Okay, we're doing Inclines 5. Here we have the a cart sitting still, so it's on wheels, so there's no friction, and it's held in place by a horizontal force, so it's not accelerating. Okay, so the forces on it, again drawing the ramp is fairly shallow. We have a normal force coming out of the plane. We have mg pulling it down, and we have a horizontal force F pushing into the, pushing straight left, flat left. Alright, so our acceleration is 0, so it doesn't matter in particular which way we tilt our axes, but I'm going to not tilt my axes because it's going to let me do less work here. So if I tilted them, I'd have to break up f and mg into components, but if I don't, all I have to break up is n. So it's just going to make my life a little easier. So theta is that small angle again. Looks like my f is I drew my f too big, so I'm going to revise that a little bit. I want to make sure that it's balanced. I want to make sure that this vector goes all the way up too. So just revising my little prototype here. So the a is 0, so both f nets are balanced. In the y dimension, I have n cosine theta minus mg. I'll go right and up as positive. And that dimension is balanced, as is this dimension, where I have n sine theta balanced by f. I want to solve for the magnitude of f. I'm going to need to know n to do that, so I'm going to solve for n. So n is mg over cosine theta. And I substitute that in. Move f to the other side, and I'm going to get mg tan theta to be f. So that's 20 newtons is the weight, m times g, and the tangent of 20 degrees, what we get is 7.28 newtons. So in this one, the m didn't cancel out. That's because the force F doesn't depend on m. I mean, it depends on m, but it's not like mg, right? There's an explicit functional dependence on m. For the normal force, that always changes with m, even though that's not the only thing that determines it. M is in there. So the m's would all cancel out, but F doesn't have that. So the m stays in here. The heavier this box is, the harder you're going to have to push to keep it in place.